For classification of the impression materials, we have different ways for classification, but the most important way is the classification according to elasticity of the impression material after setting. Okay. So the impression materials are classified according to elasticity into two groups. The first group is called non-elastic impression materials or rigid impression materials, and the second group is called elastic impression materials. For the non-elastic impression materials, we have plaster of Paris, compound, and zinc oxide eugenol impression material. For the elastic impression materials, we have hydrocolloids and elastomers, and hydrocolloids include agar and alginate. Elastomers include polysulfide, silicones, and polyether. So what is the importance of classification of impression materials according to elasticity after setting? Of course, we know here that if the material is rigid, so it is indicated only for edentulous patients without undercut. As we said before, rigid impression materials are used only for edentulous patients without undercut, because we said that the rigid impression material, when it gets inside the undercut, this will be difficult to be removed from this undercut without breaking. Okay, so rigid impression materials are used only for edentulous patients without undercut, while elastic impression materials are used for dentulous or edentulous patients without any problem, because they can record the undercut and get out from the undercut by their elasticity without any breaking. Here is an important notice. We have to notice that the flow of the impression material before setting determines the ability of the material to record fine details. As we mentioned, if the material has high flow, it will get inside the fine details and record them very accurately. So it determines the type of tray used. If the material, the material has high flow, so it will record fine details. So I need fine details in the secondary impression. So in this case, I will use which type of tray? It is the special tray, not the stock tray. The other thing is the elasticity. We measure elasticity of the material after setting, not before setting. Elasticity after setting determines the ability of the material to be removed from undercuts. Okay, so this determines the type of patient. So if the patient is edentulous without any undercut, so I can use the rigid impression material. But if the patient is dentulous and has any undercuts, so I must use elastic impression material. We have another classification of impression materials according to their setting reaction. We have some material that's set by physical reaction and others set by chemical reaction. And always the physical reaction is reversible because it depends on heating and cooling of the material. So when I heat the material, it will be soft, and when I leave the material to cool down, it will become hard. So this is a reversible reaction. So always the materials which set by physical reaction are reversible and reusable. I can use them many times, but of course after disinfection. The materials that set by physical reaction, we have a material called impression compound. We have agar. But for the materials that set by chemical reaction, these materials during setting undergo a certain chemical reaction. So I can't reverse this reaction again, so it occurs one time only. So we call these materials irreversible impression materials. We have zinc oxide, eugenol, alginate, and rubber base as examples for the chemical reaction materials. Today we'll talk about the rigid impression materials. The first example we have is the impression compound. As we see here, the impression compound, it comes to me in the form of sticks or sheets, as we can see. These sticks and sheets are softened. They come as hard material, as you can see. They are softened by heat. So we heat them to become soft, and then we can use them. That's why you call this material thermoplastic impression material. Thermoplastic means that this material is softened by heating and hardened by cooling. And this is the idea of using the impression compound. We soften it by heating, then put it against the oral tissues in the soft state, and let it to cool down. And after cooling, it becomes hard and set, and then we can take it out from the oral cavity. The composition of this material consists of thermoplastic materials. This gives the thermoplasticity which we talked about. We have some fillers to give body of the material. We have plasticizers to act as lubricants and control consistency of the material. We have coloring agents to give characteristic color. Now, what are the types and uses of impression compound? Firstly, we have type 1 impression compound is called lower fusing compound, and it has fusing temperature below 70 degrees Celsius. We have three forms of this, three uses of this material. The sheet form, which we saw before, this is used for taking a primary impression for edentulous patient and without undercut. And why do we have to use it for primary impression and for impression for edentulous patient without undercut? Firstly, primary impression, because the material, as we will see later, its flow is not very high, its flow is low, so in this case it will not record fine details. That's why we have to use it to take primary impression only. And it is used for edentulous patient without undercut. Why? Because this material is rigid. After setting, it will become rigid, so I cannot use it with any undercut. The second use is for the stick form. The stick form, we see here the stick form. It is used for what we call border tracing. What is border tracing? During taking the impression for completely edentulous patient, we need to record the details of the sulcus, oral sulcus, and to take this part of the oral cavity to take the impression of the sulcus. We can use this stick form by heating the sticks, and then when they become soft, as we can see here, we put them on in the borders of the tray. Then press them against the oral tissues to record the details of the sulcus. Okay, because this part is very important during making a complete denture for the patient. The third use of this type is also for the stick form. Some sticks are used for recording an impression called copper band impression, and the copper band impression is used to take an impression for single tooth only by heating the sticks and making them soft, and then putting them in a copper band which is pressed against the tooth to take a primary impression also for a single tooth. The second type is called higher fusing compound. The high fusing compound has fusion temperature that is above 70 degrees Celsius. Okay, so at this temperature I can't put the material inside the oral cavity because the patient cannot bear 70 degrees. This will cause a thermal shock to the patient. So I use them outside of the oral cavity by pressing. When I make this material soft, after softening, I use this material to make a special tray on a primary cast of the patient. Okay, so this material, the higher fusing compound, is used only to make a special tray for the patient. The technique used here is called the wash impression technique. Now about the setting reaction of impression compound, we said this material undergoes a physical reversible reaction, which is thermoplastic reaction. The material comes as a hard material, and for softening of the material we use hot water at 45 to 55 degrees. And then after putting the impression inside the oral cavity, we let the material to cool down, and at about 35 degrees the material becomes hard again. So this is the setting of the material, and as we can see, it is reversible. How can we use this material to take the impression? For manipulation of impression compound, we have to soften the material firstly. To soften the material, we use hot water bath to soften the material. And during softening of the material, we must knead the material under hot water to make it soft, and then we put the material in the tray to take the impression. As we can see here, the material has a very low flow. It is a very viscous material. So which type of tray do we have to use? Of course, this consistency will not record fine details, so we have to take primary impression only with this material. So the type of tray used is Tuck tray. When we put the tray inside the oral cavity, we let the material to cool down. So after complete hardening and cooling of the material, we remove it out from the oral cavity, and then we have to sterilize the material by autoclaving for 10 minutes. So what are the properties of the impression compound? Firstly, this material is not very accurate because it doesn't record fine details. So we use it only for primary impression. The material undergoes some shrinkage, so the dimensional stability is not very high. About the elasticity, we mentioned that this material is rigid. It becomes rigid after setting, so it cannot be used for dentulous patients or for patients which contain undercut. The material is compatible with the cast and die materials, so it doesn't need any separating medium before pouring the cast. And after pouring the cast, we can separate the impression from the cast only by some warm water. As the material is reversible, so it can be reused, but of course after sterilization. A very good advantage of impression compound is that it can be added or corrected because it is reversible, as we mentioned, and it is not toxic material. It has a suitable setting time, it has a long shelf life, and it can be copper plated. The next rigid impression material that we will talk about is the zinc oxide eugenol impression material. It comes in the form of two pastes, as we can see here. Two pastes in two collapsible tubes. The first paste is the base paste, and it is white. The base paste contains zinc oxide and it contains inert oils. The catalyst paste is red and it contains eugenol. It contains gum rosin and oils. It contains magnesium chloride or zinc acetate as accelerators, and it contains moisture, and this is a very important component of zinc oxide eugenol, and we will know why. Here, this is the setting reaction of zinc oxide eugenol material. The setting reaction here is a chemical reaction called chelation, so it is irreversible because it is a chemical reaction. The reaction here takes place on two steps. The first step is called hydrolysis, and during hydrolysis the material reacts with water. Okay, so the zinc oxide, which is the base paste, reacts firstly with water to give zinc hydroxide. Okay, so the first step is the reaction with water. The second step is the chelation reaction. During this step, the zinc hydroxide reacts with eugenol to give zinc eugenolate, which is the set material. So we notice here that the first step is the reaction with water. That's why I said that moisture is a very important component of zinc oxide eugenol paste, because if it doesn't contain moisture, so the reaction will never happen. That's why the moisture must be included inside the components of the catalyst paste. To control the setting time, we can accelerate the setting time either by heat or by chemicals like primer alcohol, or by water or saliva to accelerate the reaction. How do we manipulate zinc oxide eugenol? We take two equal lengths of the paste on a waxed paper pad, as we see. Then we mix the two pastes until a homogeneous color is obtained. Then what is the type of tray? Then we take the material to the tray. What type of tray we use here? We said that the type of tray is determined from the flow of the material, and as we see here, as the material is a paste form, so it has a good flow, it has a high flow, so I can use it for taking secondary impression. That's why I use a special tray. but here the special tray must be made from acrylic or compound, but shellac is contraindicated with zinc oxide eugenol, as zinc oxide eugenol may affect the shellac material. To put the impression material in the tray must be dry to allow complete adherence between the tray and the impression material. Then I put it inside the oral cavity and let it to set for about 3 to 5 minutes. Then I take it out from the oral cavity and disinfect the material and pour it without any separating medium. It doesn't need any separating medium, so it is very compatible with the cast material. What are the properties of zinc oxide eugenol material? As we saw here, the material has a good flow, so it can record fine details. This is a good property. For dimensional stability, the material has no or very little dimensional changes, and this is also a very good advantage. For the elasticity, the material, as we said, it is not elastic, it is a rigid impression material, so it is contraindicated for patients with undercut. The material also can be added or corrected, and this is a good advantage. It is compatible with cast material, so it doesn't need any separating medium to affect the accuracy. A very common disadvantage of zinc oxide eugenol is that eugenol is an irritant material, so it causes some burning sensation to the patients. That's why we have a new material from zinc oxide paste. It is called eugenol-free zinc oxide paste. For eugenol-free zinc oxide paste, here the eugenol is replaced by a material called ethoxybenzoic acid. This material will give the same similar reaction to that of zinc oxide eugenol, but here with little irritating effect. Okay, in this case, the catalyst is blue rather than red in zinc oxide eugenol. The setting reaction here is called saponification rather than chelation of zinc oxide eugenol. What are the uses of zinc oxide eugenol paste? It is used to take secondary impression for edentulous patient without undercut, and we said secondary because it has good flow, and for edentulous patient without undercut because it is a rigid material. It can be used for wash impression technique or double impression technique, in which we form a tray of compound firstly, and then we put a layer of zinc oxide eugenol to take the secondary impression. We can use the material for taking impression in an old denture for relining if the denture needs relining. Thank you.